this computer. Let's see how it goes. All right, so I'm gonna get started. This lesson won't take too long. Repeating myself for some of you. Hey, Jeff.
Hey.
I've built an FTP server at home on my gigabit. So while you guys are doing the labs, I'm gonna create you some user accounts. And then when you're done the labs, we'll go through an exercise of how to connect to it. And on there right now are the VMs for the Exchange module that's coming up. So that's what we'll do with the back half of the day. But for now, let's talk about, can't minimize, fine. What do I want? This should be all I need. Got to share something. That's right, Rob. Share something. Share the PowerPoints. All right, there we go. Thank you. I'll be editing out the cough. So the SQL Server management, right, is done. Exactly. I don't know how it goes through the internet. Is done through a component, the SQL Server Agent. So it's basically a piece of software, a combination of services in the background that checks to see the list of jobs that you've created and manages those jobs by starting and stopping them at the appropriate times. There is a thing in Windows called the task scheduler, and it's fairly old school. So back in the day when you wanted to automate a backup, for example, you'd create a backup job and you'd go to this thing called the task scheduler and you'd say, run my backups the following days. This is similar to that, but it's more complex. As we go through the content, you'll see that you're effectively creating either links to scripts, links to command.exe batch files, links to PowerShell. So you can put a whole bunch of 4 different flavors of active tasks to perform functions, link it to the SQL Server Agent, schedule it, and have it run. There's some convenient ways that you can take activities that you've already created and have those activities generate jobs and link those jobs in. So we'll talk about that. So management, the agent, managing the jobs you create, and then if you have multiple SQL servers, you can use this multi-server management facility, effectively create a backup job on the master, and the master tells all the other target servers, hey, I want you guys to run this exact same job, and it gives you the ability to centralize the control, which is handy. We'll talk about the benefits, different options, overview, right? Then I'll jump into the SQL Server Agent and show a few examples of creating jobs, right? As with most things with SQL, you can do it through the GUI or you can do it from the command line as well. You can do it with SQL scripts. So there's a couple examples of that. So why do we do this? To make our administrative job easier. The author talks about some IT people, database guys, whatever it is, right? They will do all their tasks as one-offs. So you need to create a brand new user, no problem. Go to the domain, users and computers, make the person, right? Away you go. You can do it one at a time. Other people who are either creative or lazy or a combination of the two will say, hey, wait a minute. I can do this way faster if I get HR to give me a spreadsheet of new people that are starting, like, for example, a new class of students at Willis. And I can import this spreadsheet and make an LDIF file. You guys might remember LDIF back from Server 2012, one of the ways of automating commands. And we'll pull this thing in and ta-da, hey, it's all done. And I can go back to playing my games or drinking coffee. This is the same kind of thing. A lot of tasks you can do administratively on SQL. You can just do onesies, or you can create a script, create a job. Besides the convenience and time saving, it reduces the possibility, theoretically, of error. If you have to type a friggin' SQL script that's long every single time you do it, you're bound to make mistakes sometimes. Sometimes the mistakes might just generate an error. Other times the mistakes might be catastrophic. So the idea is you craft it up once and then reuse it every single time. If there are changes to be made, so say, for example, it's a master target type scenario, and you suddenly decide we're putting our backups over in this location instead of the previous one, you change the original job, you push the update out to all the target servers, and now one change percolates out, hits all 40 of your SQL servers, right? So it improves the ability, right? So execute routine tasks reliably and consistently. And then proactive management. So on top of making these jobs and firing them up, you can go back and actually get a job history. So you can double check to see if things worked. We discussed yesterday that if you're restoring backups, it really sucks to go and look for the backup and it's not there. Well, now if it is a job and you remember to check on a regular basis, because you could still forget to do that, you can confirm every day, yeah, backup successful. Part of the process with the jobs is that the jobs can also create alerts, which means after it's completed, it could, in theory, fire off an email message. So the textbook talks about one of the ways to do it is with the SMTP protocol, and you recall that that's the back end for sending emails. So automate this process. There are other tools that you can use besides these built-in ones through SQL to do some of these tasks, but for a starter, this works pretty well. So how can you do your overall automation process? So here's just one of these tools, System Center Operations Manager. So Microsoft will happily sell you for an extra additional cost this interface that will act as a overall unifying management interface. Yes, you can create PowerShell scripts. So if you recall from previous modules, we talked about that there is a collection of commandlets that you can upload into PowerShell, and those commandlets are all SQL Server centric, so you can do that. The agent that we just talked about at the top, which is what we're going to focus on, and then maintenance plans, which is also a SQL Server concept, but it is different from SQL Server Agent. It'll allow you to do certain functions, automate a few of the day-to-day maintenance tasks that are would be difficult to do with just doing the job wizard, right? Things that run behind the scenes. It'll go and create the jobs for you. So the maintenance plans is almost like a bolt-on tool on top of the SQL Server agent that says, hey, agent, I dynamically need a job that does this. So all these things will let you automate the process. Wink. So what is this thing called SQL Server Agent? So whenever you see agent, always think process, always think service, right? An agent is a little piece of code that sits on a system and runs in the background. And as things happen, it responds to these events. It runs as a service in Windows. That's the default. If you recall looking at the Service Manager window on a Windows machine, remember you can start and stop them, right? You can choose whether they start automatically or whether they're disabled or whether they start manually. So therefore, if you decide this is a great thing to do, you have to go into the Service Manager and change it from its default, which is manual, unless that's your intent, but it's probably not your intent. So if you decide you want to deploy this as a constant mechanism, you need to go into the Service Manager and put it on auto. Any individual job can do a number of tasks. Any individual job can be a whole bunch of steps. There is a ability to have a logic flow in these jobs. So it's almost like you're programming a little bit. You could have something that says, run this step, which is back up the file. And then, oh, on the event that this is successful, move on to back up the next file. Oh, on the event that this failed, jump over here, right? And this particular step is going to, send out a message to alert the operator that something's happened. Why did it fail? Maybe it failed because a service wasn't running. So you have another step that goes over and fires up that service. So you can build these individual steps, and there's the ability to link them together logically, almost like an if-then type scenario, and then also associate alerts with it. You can create schedules for your jobs. So you have a backup job, and you say, run the backup Monday through Friday. A schedule can actually run more than one job. So maybe you have, at the end of every day, you run a backup job, and you run maybe an archive job, and you run a job that checks the database for consistency. So you create a schedule and tell that schedule run job 1, 2, and 3. Schedules can have many jobs, and jobs can be associated to many different schedules. So you may create a schedule called weekday backups, and it runs the same backup job. And you create another schedule that's called weekend backups, and that one runs the exact same backup job. So it's a many-to-many type scenario. Alerts can happen to respond to system events. And then operators, right? That means you and me can be notified by jobs when certain things happen. Could be good news. Hey boss, backup completed. There's an email in your inbox that lets you know. It could be bad news. Hey boss, backup failed. There are jobs that can be there that monitor system status. We don't go into that in here, but you could have jobs that are sitting there making sure that, for example, the master database is there and is functional. If you recall, I think it was yesterday, if the master database is corrupt, then nothing runs on the SQL Server. That'd be handy to find out about. Again, if nothing's running, then your server agent probably won't be running, but you might get lucky that you get a dying gasp from the server agent that says something's going sideways with the master data, and then end of message. Where'd we go? Oh, I must have more to talk about before I do a demo. Schedules, alerts, operators. No, apparently not. Okay. I will switch screens shortly. Yeah, this old chestnut. Oh, that's a better one. Okay. Right. So stop sharing that one. I'll make a new share. Here we go. New share. This is screen one. Say share it. So do you guys see screen one, or do you see my PowerPoint still?
We see your SQL.
It's my SQL. Okay, great. It's just normally I get a green box around it and it didn't pop up on it, so that's all right. Okay. All right, so I've already gone through the steps of logging in and uploading my test data and etc. We're on our SQL Server instance here. There is the SQL Server Agent that we're talking about, and then here's the different zones such as jobs and activity monitor and alerts. There are already jobs. I was tinkering, so I already made something called manual adventure backup in this, but there are other ones that are in there. There's some maintenance jobs, right? Sys policy purge history. So there are already jobs that are there, but you can make your own. Looked at it, right? So how do you do it? You right click and you say new and you say job, for example. And I'll call this one, I don't know, another backup, because I already made one before. You can pick and choose categories for conveniently grouping things together, right? Also, certain categories also enable certain services and capabilities. Backup would be considered database maintenance. This is another one of those scenarios where don't friggin' click OK until you've wandered through all the tabs, right? Otherwise, you got to go back in and open it all up. It'd be nice to give it a description. And when I say would be nice, I'm not actually going to do it. On the steps, so this is all the different individual chunks of whatever it's going to do. So I can say make a new one. Usually you give these things meaningful names. Sure, okay, fine. Backup ADV, backup Adventure Works. And cut and paste works from the PDF. Woohoo! So instead of typing my life away, just copied that. So this is a step in this job. This is what it's called. And here's the script, or sorry, here's the SQL it's going to run. And this kind of looks familiar from yesterday. Backup database Adventure Works to disk, right? Backup, I'll call this backup 2, since I already named it. Right, and we're putting compression on, etc. And are we going to schedule it? No, this is a one-off. Okay, so I'm going to do OK. If we wanted to, we can come back and we can do some scheduling, but we're not going to. So we got the general name, we got our steps, we clicked OK. There's my job called another backup that I just made. And to fire these things up, you can do it from here. When you fire them up, you use the start job at step. It gives you the flexibility to open up the job, and if your job had multiple steps, maybe you don't want the whole thing running, you actually want to do thing number 3 or thing number 2. But we can do start job at step. Mine just had 1, so it's letting it rip. This is telling me that I did start your job. We're waiting for this last part to complete because it's going to tell us whether or not it worked. So that's telling us that it ran that piece of SQL code and it didn't find any syntax errors. If you had a file path in there that didn't exist, right, it would have blown up. So this is kind of a good indication that it did what we said. We do have a few options here. Job activity monitor. Wink. All right. So I double clicked on job activity, and here it basically says, here's what's happened. This was me playing before. This is me running some check that was supposed to fail. And there's the backup. It ran, last time ran, etc. Runnable, scheduled. No, it's not scheduled, category. So this is where you can go to see what's been going on with regards to jobs. And where did it put that backup? Oh, wait a minute. Let's pick the right one. Okay, you're way too big for your britches. Oh, there you are. Sorry, I'm getting confused as to where things are. So there was the backup 2 that we created. So it generated something. Looks like it did its job. Okay, stop that share. Start a new share. Meanwhile, back at the PowerPoint. Everybody see my PowerPoint?
Yep.
Thank you. All right, so you saw me make a job. So we're going to have a discussion about jobs, types, categories. Already showed you a category. I made that one database maintenance. Creating the job steps. Well, I did one, but you can create multiple. Scheduling, as I mentioned before, pick and choose when it's going to run. Scripting jobs. So it's kind of handy. We saw a bit the other day when we had a function we were running, and we said, hey, as we're running this backup, can you please show me what the SQL is that you're actually executing that corresponds to this, right? A quick and dirty way of creating SQL code without having to type. There's even more features that are related to that is handy when it comes to creating jobs. And then I will do another demo about scripting jobs. So yes, jobs consist of a series of steps. The one I made before just had a single step. It could have had step number 2, and it could have went and done a database check to make sure that nothing was corrupted. What can be inside the steps? Again, it could be a command line script or a batch of commands. So literally, you could jump to like a DOS window and run the copy command, or delete star.star. So you can run that. It can be SQL statements. That was the job example I already did. It could be a PowerShell script that fires up, or it could be using some of the more advanced integration services and access services commands and queries. So you have all those options, and you can mix and match as well. So you could run a SQL command, and then you could sort of shell out to the command.exe and run something, and then fire up a PowerShell script. So you can pull a bunch of things together. And you can assign the jobs to different categories, right? And the idea with categories is that it gives you a way to unify and classify. If you're curious, what are all the database maintenance jobs I have in the system? Bam, you go and filter by that, and you can see those specifically. And here's a little flow chart. So you have a job, right? Job may have multiple steps. You fire up the job starts, right? What's the first thing that it does? First step would be backup database. So that's what we had in our job, that one step. If it's successful, then there could be another activity that basically transfers data. So maybe it takes the backup and copies it from where it is on this server to your secondary archival server, right? So that could be just a straight on command.exe copy command if you wanted to. After it does that successfully, then maybe it goes and executes an application. What is that application? Well, that application could be, for example, send email. So it runs that and says, hey, tell the boss everything's good. The application could also be maybe a cleanup. Now that we've transferred this, let's get rid of this backup off our main server. If everything is a full success path, then it does the item over here. It'll be successful. And if you choose to notify the operator, right, you can fire off some kind of alert. Any of these failure scenarios, the job will fail, right? It'll write to the application log the fact that it failed, right? And then potentially fire off a notification to the operator. Towards the end of this module, we troubleshoot an existing job that has an error in it. And you have to basically dig into the job history, find out that it failed, figure out what line it is, and then determine what the error is, right? And the errors could be things such as a syntax error, which means somebody got the command wrong and it's just not a known command. An error such as you're trying to copy it to a location that doesn't exist. Maybe the transfer data section here is trying to move it over to file server 47, and file server 47 is offline at the moment. So that would fail. One of the features is that you can tell failures to retry. So you try to copy the successful backup over to the other server. It's not online. Okay, wait 30 seconds, try again. Wait 30 seconds, try again. Do that like 5, 10 times. If after 10 times, waiting 30 seconds each time it doesn't work, then just move on and full on fail. So there is a little bit of error handling that is capable. Don't know if a slide pops up for this, but you can do this programming, adding job steps using SQL or through the GUI as I did. Bottom of page 810, it shows you how to, in fact, add a job step to a job that is called HR database backup, right? So that's basically the code that's there. All those @ sign things are individual variables that are part of it. And I mentioned before the fact that you could do a retry attempt and a retry interval. So that exists at the bottom of that page. And let me see here. Let me jump over here. Can I share that? So I think I'm sharing the PDF of the book now. So this is what I was talking about. Through SQL code, if you executed that, that would actually add a job step to this overall job, and the step would be called that, and it would be telling it that you're running a piece of transact SQL code, and there's the actual command, alter database, and here's the try it twice if it fails, and wait the default time is minutes, so this thing would wait 2 minutes every time this command up here failed. New share. Meanwhile, back to the PowerPoint. So recurrence, it's a one-off, one time. You can have it start up when the SQL Server agent starts. So SQL Server is offline, it comes back online, agent fires up, runs a job. Maybe that job is just basically generates an alert saying SQL Server agent up. That would be useful because that would imply to you that, hey, it must have been down if it told me it just came up. Why the heck was that thing down? Right? You'd go and backtrack to figure out why your server was offline. Or possibly when the CPU is idle. Later on, when we talk about multi-server control, where you have a master that's telling all these targets to do things, the author mentions that being the master means you have an extra workload, and having this extra workload isn't a great idea to maybe make one of your main SQL servers the master if you're going to have this controlled environment, master target, you probably want a standalone server that isn't doing much, and it's mostly its whole job will be telling other servers what to do. Related to that is that you can have certain jobs that says, hey, this server isn't doing very much, CPU is idle. This is a great time to, I don't know, maybe compress databases, maybe compress and do some archives, because if you recall, compression and encryption puts a CPU load on your server, so it might be a good time to do that. One job can have multiple schedules. Multiple jobs can share one schedule. What do they mean? You create schedules, runs on Tuesday. You create jobs, does a backup, does a compression. You can assign backup compression to Tuesday, right? Or you can have backup assigned to several different schedules, right? So they're all mix and match many to one. If there's already a database task or a database function that you can run, this is where you can use the script to feature to say, hey, while you're at running that, please record all the SQL that you use to do that so that I can take that and maybe copy it into a file or put it into a job. And hey, I didn't even have to type that job. I use SQL Server to do it for me. So you can generate scripts and tag those on the end of existing jobs. So you have a job that does step 1, 2, and 3, and you say, hey, I want to do this following thing. You tell SQL Server to script, and you cut and paste that extra piece of code and drop it into your steps. Oh, and I guess that's what I'm doing. All right, new share. Screen 1, hello. All right, my SQL machine should be up. Excuse me, coughing. All right. Adventure works. So this isn't the jobs. This is just running tasks inside of SQL. So this is this whole concept of scripting things, right? Right. So I can run a backup, for example. Well, we did this before, didn't we? Hey, look, and I already have it in here. That's handy. Okay, so backup destination. So we're creating, this is a backup job, not one of these scheduled jobs we're going to talk about. So in this scenario, I'm going to remove that. I can cut and paste. Now you're going to be like that. Fine. I am copying. Add a new one. I'm going to paste. I'm going to call this 2. If you're cutting and pasting, watch for random stuff on the end of your lines, because I accidentally copied the comma. I didn't want that. Let me see here. All right. Click OK. Okay, so that's going to run it. So this is just running a backup. This has nothing to do with us creating server agents jobs. This is just a normal backup that we might do. Okay, so did its job successfully. If we go over here, the demo files, module 8, backups. Okay, made that backup 2 for us. So it looks like it did something. So then, and oh, I wanted it back. Asks backup. Here we go. There's the script to thingy. So I didn't want to leave at this moment. I want to either have it script to a job, script to a file, script to clipboard. So if I wanted to, I could basically say script to job. Now it pops into the new job zone. So now we're talking SQL Server Agent jobs. And we can call this backup 2. And it's already created a step for us. So that's effectively the script too. It says, hey, what is the script that would be created, the SQL code, if I ran a backup? Don't actually run the backup this time. Just pretend you're running it, but you're actually going to create a job for me. And here's where you can use the scheduling feature. So now this, I don't want to make this a one-off. I want to actually do this on a regular basis. So we'll call this backup 2. It's recurring. Let's do it Monday, Wednesday, yeah, Tuesday, Thursday, okay, whatever, Friday. Pick and choose the time, etc. Here's basically a summary of when it's going. So that's there. Right. Alerts, didn't do any notifications, not going to bother with that. New job box, we'll click OK. Now we're back at the backup the database thing. So if we clicked OK, it would like run it again and make a backup, but that's not our intent right now. We're just trying to create that script for the job. So we cancel this. But if we look over here now, we have a job called another backup. And if we wanted to, we could start job up step and have it fire up. Oh, all right. So what am I going to do here now? Right click, check adventure DB works. Okay. So we're doing the other part. So we have this previously existing job. So what we're going to do is we're going to take this one and find a way to extract the SQL code from it. So we can do a script job as, and we want to create it to, and I think we're having to go into the clipboard. Yep. So what did it do? The script for that job is now sitting in our cut and paste buffer. And now we can go somewhere and actually paste that in. And who we're going to do it? Backup database, another backup. So there's our steps. All right, there's our SQL code. So I double clicked on that step to see the code that was there. So if I wanted to, I could, and I'm going to, all this stuff has just been added to the end of that step. So I've increased the amount of code that's on there because I got this Check AdventureWorks database to run and generate the code, put it into the clipboard, and I put it in there. And now the overall SQL for this is more complex than it was before. And previously, I had saved this and made a file called createjobs.sql. Oh, don't do that. Yeah, sure. Let's open it in Notepad. See how that renders. So this was the code that showed up in the original step, but this is the SQL code that we just pasted. So you have a few options. You can take it, generate it, copy it to clipboard, drop it into an existing job, or you can take it, create your own separate SQL file, paste it in there. So quick and dirty ways of generating SQL to extend some of the jobs you've created, etc. All right. Stop sharing that. Make a new share. And let's go back to the PowerPoint. So we created jobs, we've created schedules. Hopefully these things are running on a regular basis. How can we double check on that? This is where the job history is handy. So you can go and view the job history. You can go and check system tables and have different views. So recall that SQL has databases and tables, right? The primary file group, all those things that SQL uses to manage and keep track of things over and above the user data. So you can actually query those tables to find out what has happened on the system. You can also look in the GUI. If a job stops working, what are our options for troubleshooting? I'll show you that, and then I'll have a demo that walks through troubleshooting. So as I said, jobs that run, the history, success, failure, time, etc. It's written to tables inside the master database. You can pull that data out by running SQL queries. You can jump into the Management Studio GUI and look at the log file viewer. And optionally, information can be written to log files. So you could have your job, upon successful completion, goes and writes a log to perhaps one of the Windows event viewer logs, like application or something, or your own very log file. So you can create your own logs and write there. And there is, as we've already seen on the screen before, the job activity monitor that will show you status of current jobs, schedules, right? Active jobs. One of the things about scheduling is that if a job is already running, you can't make it run on top of itself. So if, for example, you have a scheduled job that runs a backup 2 p.m. on Tuesday, and it starts up, and then at 2:01 p.m. on Tuesday, you manually come in and right-click it and say, run this thing now, it won't let you do it. So there is this restriction that if a job is currently running, you can't make it, run concurrently on top of itself again, right? That will fail. If you want to dig deep into the databases as opposed to look at things through the GUI, and if you're interested in the historical information about any of the job executions, right? All that stuff is contained, again, master database inside the DBO object. History tables, right? So you can pull together job history over several systems. We're going to talk about creating a master and a target type environment in a bit. If you have a master that tells all the target servers, U12 SQL servers run this on such and such a time, the successful execution of those will be pulled back and collated into that one server. So you can go and look at the history table on the master server and in fact see that 10 of the 12 servers were successful, 2 failed. What the heck's up with server 11 and 12? Right? You go and look and you find out some IT guy went and renamed the folder that your backups were supposed to go to, and that's why those failed. So again, we're going to talk about master target scenario in a multi-server environment, but the history on the server that spawned these up will keep track of it. And the job history, right, contains information for all the steps for every jobs. If a job has 4 steps in it, there'll be an entry for step 1 works, step 2 works, step 3 works, step 4 works, and then there's an extra one in there says, hey, the whole thing worked. So if you see something that has a step ID of 0, that is the summary step. So that being said, you can query this table and say, hey, just show me everything that's a step ID 0, and that will give you a summary for each of the jobs. If you say, I know something went wrong, don't show me the summary, show me a detailed report for every single step, 1, 2, 3, 4 for all the jobs, then you could filter out and not look at step ID 0. A job ran, didn't work, why? So recall from a couple slides ago, we said the SQL Server Agent service has to be running in order for this to work. If it's not running, it'll fail. For services to start up on a system automatically, it has to be associated with an account to run it that is valid. So that would be the service account. These accounts have credentials, they have permissions. is the service account actually valid? Usually all your SQL servers are part of your domain and things are linked together, which means you could use a domain-based account with privileges to fire these things up. That would be a convenience, because then you're using one service account with domain privileges to fire everything up. But whenever we have something that is a convenience, right, that always implies that that may be a security risk. So therefore, you might be using local accounts on each individual server to fire up the service account, which means that since they're local, you can't manage them all from one spot, which means there is a possibility that some IT guy went over into server 7 and messed with the settings on that service account, and your multiple targets, everybody ran except for this guy. Why is server 7 not running jobs? Because the SQL Server Agent on that box is offline. Why is it offline? Because it couldn't start up, because a service account got rejected because this IT guy went and changed something. If the MS database isn't online, then nothing can run. So you've got bigger problems than just why aren't my jobs running, right? Everything on the SQL Server is down. Job history will show you the outcome of the jobs. You can also use the job history if things fail to figure out which step didn't succeed. 1, 2, hey, that worked. 3, big red X. What happened with 3? For job execution, jobs can be enabled and disabled. So just because you went through and did a whole bunch of coding on something, right, doesn't necessarily mean that the job is going to run. So you could have properties on here where somebody actually shut that thing off. I'm not going to do that. So is it enabled or disabled? Is the job scheduled? Oh yeah, I put in all the steps for backing things up, but I didn't tell it when to run. And same thing with the schedule. So if you create a schedule that says schedule weekday backups, Monday, Tuesday, all the way to Friday, if that is not enabled or disabled, then it won't run. And then there can be dependencies, right? Are all the dependent objects available? If your backup, when it's done, wants to copy the backup to file server 47, if file server 47 is offline, then it can't do the backup. So you have to look at the big picture. And we're going to be troubleshooting. All right. I'll switch screens in a second. All right. New share. SQL machine. Doop. All right, we're on the SQL machine. So here's a backup job that we made before. All right. Start job at step. Okay, so that ran. So now we have a different job, whatever this one is. Start job at step. And we're gonna let it rip. Click 1. Okay, start. So that one does 3 things. So something worked and something didn't work. So execution of this failed, right? No. See the history log for details, right? So it's telling us basically you got to go look at the history log to figure out why this didn't go. So we're going to look at its history. Okay, I ran this earlier, so there's a history of a couple failures, and that's way too early. So it's got these plus minus boxes, right? So the plus basically means expand. So show me greater details. So it says step 1, good. Step 2, good. Step 3, not so good. What was step 3? Oh, hang on, before we go there, we can scroll down here. Maybe I'll make this bigger. So you scroll down and it says something about execute as a VentureWorks service account, incorrect syntax near word check, blah, blah, failed. Okay, so it's kind of telling us that there's a syntax error. So whoever created this must have made a typo. Now here's our job. So maybe we haven't done this before, but if you actually double click these things, they'll pop up. So there it is. Here's our steps, right? Step 3, it says was a problem. I double clicked on that step again. So let me just back out. So I went there, double clicked, right? It's basically saying, okay, what's going on here? So we got a syntax error. Somebody forgot to type the command wrong. Let's check database. Let me click OK. Let me click OK. Start job at step. Start. Hey, didn't complain. Job activity monitor. Okay, check VentureWorks DB, last run, success. Okay. Right, check Adventure DB. So last time it was run, and I'd ran it before. So this is the latest and greatest. So yeah, we corrected an error. Oh, and apparently there's text files generated by this job. Oh, it's module 8. VentureWorks. Okay, there's the DB check and there's the DB info. So wham. Okay. SQL state, rows. Okay, so this is all the database check. So it actually ran the database check. There's a timestamp where it ran, and it's going through all the individual objects to check and see for consistency, to see if there's any errors. Okay, so 0 allocation errors, 0 consistency errors in database. So that's a fairly good report. It means it was healthy. And DB info. And it's basically telling us that we ran the check VentureWorks DB. Step 2 did this. So this is a text log that was generated by the fact that we ran the log. That's right, ran the job. And extra info that's there. All right. Stop share. Share. New share. How are we doing for time? We're doing good. All right, and the last conversation for this module. You have multiple servers you want to control. So this is our multi-server management concept. Things you have to plan, organize, considerations, right? I'll show you how to set one up. We'll see if mine actually works because mine was being hit and miss. And when you get to your stage, we'll see if yours works. Running jobs in the target server, right? And then automating the whole process. So the idea here is that you designate one of your SQL servers, and it's going to be a SQL server because you're going to be creating the jobs inside the SQL Server Management Studio. It will be the master, and this master will hold copies of the job definitions. It's going to distribute the jobs out to the target servers, and then when the target servers run the job, right, it will report back. The example I give is you create a job that does backups. And the master server tells the 3 target servers, do your backups 5 p.m. Yeah, maybe make it 6 p.m. Monday, Tuesday, Wednesday, Friday. Those will get their jobs. When it gets a job, the target server will actually add that job to its job list so it doesn't forget. and it basically remembers to run that job on a regular basis. So it's effectively independent. The master server doesn't have to send the job to it every single day. It sends it once. If the master server makes a change to the job, then those changes need to be filtered out to the target servers so they know the new marching orders. So maybe the master server goes back and says, yeah, we're now moving our backups. When we copy them over, instead of file server 47, we're moving to file server 48. You need to change that, and the master server needs to push out and alert the target servers, here's the new details. Okay, and that's where it downloads new jobs from the master server. The other thing too is that maybe you don't change the contents of a particular job. Maybe the master server thinks of another job that everybody should do. Hey, wait a minute, I had you guys backing up. I should get you guys all to do a check database on a regular basis. Here's another job you should do, right? So the master server pushes out to the targets. The target downloads the new job information, right? Stores it in its SQL instance, has it scheduled as per the scheduling directives from the master, and then the process is automated. Being the master server, I already said this before, can impact performance. So it is important not to turn a SQL server that's already challenged for horsepower into the master, because it may not be able to handle the job. If you have a lot of servers and you want to centralize this, it's a really good idea to have a SQL server that is its only responsibility is to be the master of job creation and deployment. Every target server can only have one master, right? You can't have a target server getting marching orders from multiple masters. But of course, a master server can have multiple target servers, right? You can be the master of many targets. Once you have reached out and say, please make SQL Server 47 my target, you can't go and change its name. So if you go on to SQL Server 47 and go to System Properties and rename that thing, well, that's going to break the connection between the server and the master. So you'd have to go back to the master, delete, right, unenlist, right, abandon the target server you had before, and then rejoin it to the master by its new name. For this to all work, since you have one master server trying to push out commands to all these individual servers, the best way to unify that is to use a domain account. So if there's any changes to the domain account, those credential changes are reflected across all the servers. So therefore, the server agent and the SQL services, right, must use a domain account. Again, that is a convenience, keeps things from breaking, but now you have your services and your control all in one basket. Also, principle of least privilege, you need to make sure that this service that you're using isn't like the domain admin or something crazy like that, because if it was, then now you've got these services that have ultimate powers and things can really go sideways. So you're going to have to craft a domain-based service account that has just enough permissions to operate inside the SQL Server Agent and SQL Server subsystems. All right. Okay, I'm going to switch over in a second. Get rid of that. My screen's all cluttered. Hello, SQL. Okay, back on my SQL Server inside the Management Studio. Again, this is a SQL Server Agent concept. So we want to do this multi-server admin thing. Right-click, multi-server admin, make this a master. We go to Wizard, it walks us through it. It wants an operator email address so it can send notifications to. And now you're trying to pick and choose targets. So this is where my demo crashed and burned before, and I did a little bit of troubleshooting, and I can't figure out what its issue is. So you will find out when you get to the master and target server part. It could have been a timing thing. So I'm hoping that the fact that my VMs have been running since I started up this morning. But there is a SQL Server 2 and 3 instance. Right, this is our default one. So I want to add this one, make it a target. And here's where mine failed. And I may troubleshoot this when you guys are doing it if it fails again. But it's not communicating with this instance. Of course, I did the standard Microsoft solution, right? Shut down the firewall. Just in the event that my adapter, my virtual adapter for this environment suddenly thought it was public and not part of the domain. You guys remember that happening before in previous modules? Yeah, failed to connect to server. And why is it failing to connect? Because this instance is refusing connections. So that didn't work. But if it did, it would have been added to it. And there's other ways to do it besides doing it through the GUI. Right? You can actually go through and add it via the code. So on this one, so we're gonna see. Okay, and I was also trying to do this. Bear with me, browse for more. Database engine, SQL Server 3, connect. Yeah, so if that had connected, I would have been executing a piece of code that basically said manually reconnect or reassociate this target server back with a particular master. So my environment setup is completely dependent upon the setup command that I had inside my demo. So that may in fact have not created the instances that I need. So I'm hoping that your setup, which is inside your lab, will do the proper thing. We'll see how that works. So this is the end of the instructional part. So jump into the labs. And while you are in the labs, I'm going to remote into my FTP server back at home and start creating individual accounts for each of you. And then when we're done lab time, we can all work together to get an FTP client on your desktops and see if you can connect into my environment. So